Hello mathletes, we are going to be looking at algebra today, graphing linear equations, and just going over the general basics of linear equations. And here we go. So, we're going to begin with the most common equation as a linear equation, which is y equals mx plus b. So this equation forms lines. Therein lies the linear equation. And the parts are, here we have our x and our y, of course, and those are coordinates that we can plug in to check solutions and so forth. But the m in this linear equation stands for slope. So the m is going to tell us about the slope of our line. It's going to let us know if it's a little bit of slope, a very steep slope, if it's a positive slope, or if it's a negative slope of some sort. And then the b is where the line intercepts our y. So it's called the y-intercept. And that's where they came up with the very clever name of slope-intercept form. So what is a y-intercept? Let's take a look at an equation. So let's say we have an equation that looks like this. So that intercept, which is the b, and in this case it's positive 2, that is where your line is going to pass through your y-axis. Okay, so somewhere along the y it's going to pass through, and this tells us where. So in this case, this line is going to pass through the y-axis at positive 2. And we can graph that point. I'll do that in black. And there it is. So I have 1 point. 1 point does not make a line, but 2 points will. So the way we use the slope from there is the slope allows us to count from 1 point on the line to the other. So in order to do that, we need both a numerator and a denominator. So of course, our denominator for 3 would be 1. So the numerator is going to tell us how we should move, how far we should move, either up or down. That's our vertical movement. And the denominator is going to tell us how far we should move side to side. That is our horizontal movement. And if you need something to help you remember where the vertical and where the horizontal is, you should think about the fact that slope makes you very happy. Vertical over horizontal. All right, so I did say up or down, I did say side to side, left or right, and the reason we have to be able to move both directions is because when slope is positive in the numerator, we are going to move up. When slope is negative in our numerator, we are going to move down. When slope is positive in our denominator, we are going to move right. When slope is negative in our denominator, we're going to move left. And that's why we have to pay close attention to negative and positive here, because positive 2 is here. Otherwise, negative 2 would be here, and the line will cross here. And we have to pay attention to negative and positive in our slope because our movement does change. But in this case, we have a positive 3, so we are going to be moving up, and we have a positive 1, so we are going to be moving right. So now we just have to create our path, and I'm going to mark it off just so it's very clear. So we have this point, and now we can form a second point by using our slope. So the slope says from any point in the line, if I move 3 up and 1 to the right, I will hit that line again. So let's see, 1, 2, 3 upward, and 1 to the right puts us right here. And there we have it. Now we've got a line we can work with. And because it is a line and not a line segment, we're going to put arrows on both ends to indicate that that line keeps going and going and going in both directions. So even though these are 2 points on the line, every single point on this line is going to be a solution to this linear equation. And what we mean by that is this. So if I take my linear equation here, and I use points that are easily detectable, such as this one. So this is, on my x, this was 1. And every point will work, but some of them are going to be very hard to figure out for us. So that's 1, 5. So that means that if I were to give myself space to plug in an x and a y here, if I put in this x and y and both sides of the equation balance, then that's a solution for the equation. So let's go ahead and plug that in. Our x is here and the x was 1. Our y is here and the y was 5. And we can see very easily this is going to work. 3 times 1 is 3, plus 2 is 5, and 5 does equal 5, which means that is a solution for our linear equation. As is every single point along this line, all the way forever and ever in both directions. Okay. All right, let's take a look at another example of a linear equation. We'll try to graph one, and then we'll try to figure out the graph for one. So let's start here. All right, so I have a negative number here, so I'm going to have that in consideration when I do my graphing. So right off the bat, I can graph my positive 4 is my b or my y-intercept. I can get that graphed, and now I just need to work from there to figure out where the next point is. So here, my slope is -3/5. And I know that this is my vertical movement and this is my horizontal movement. Now, because this is negative, this means I'm moving down. This is positive, so that means I'm moving right. So now I can count from this point and find another point that's going to fall on my line. So I'm going to move down 3, 1, 2, 3. And I'm going to move right 5, 1, 2, 3, 4, 5. And this is the location of one of the other points on my line. So now I know that the line is going to form here. Grab a line. There we go. And again, because this is a line and not a line segment, I am going to give myself arrows on both sides here to indicate that that keeps going in both directions forever and ever. And again, every single point on here, if I plug the x in here and the y in here, it's going to be some number equal to itself, which means it's the solution to the equation. This isn't necessary, it's just me counting things off. The final solution is there. So the solution for this linear equation is every single point on this line. So now we're going to do the kind of the opposite of what we've been doing, and I'm going to create a line here. And I am going to see if we can't write an equation for the line. All right, let's see, we'll give that some arrows. And let's go ahead and try to figure this out. So we know that we can figure out the slope and we can figure out the y-intercept and then create our equation for the line. So our y-intercept is right here. Our y-intercept is 1, positive 1, because it's crossing the line right here. Now, to figure out the slope, I just have to count from there to any other point on the graph of the line, and this is the one I'm sure about, the other ones I'm not, so I'm going to count here. So remember, I'm going to put my vertical movement over my horizontal movement. So let's see what our vertical movement is here. So I've got to get to this point, to this point. Our vertical movement here is just 1. I'm just going to go down 1, and I am going down, which means that is a negative 1. And then I am also going left, 1, 2, 3, 4. So that's a negative 4 is my movement there. Okay, now, as most of you know, a negative divided by a negative is a positive. So I can easily just make these both positive like this. All right, so if I go from this point to this point, then I can count it off the other way and make sure I'm correct about all this. So let's count this from here to here. We would be traveling up 1, which would be a positive 1. And we would be traveling right 1, 2, 3, 4, which is a positive 4. So we can see easily here that a positive 1 over a positive 4 is the same as a negative 1 over a negative 4. But for our purposes, we'll use 1 over 4. So our final equation will look like this. We'll have the y, we'll fit in our slope here, which is 1 over 4. We put in our x, and then we have a positive 1 as our y-intercept. And again, if we were going the opposite direction, we would have graphed that y-intercept there. We would count 1 over 4, up 1 over 4, 1, 2, 3, 4. And guess what? That point will also land on the line. And if we didn't have room to do that, what we could do is we could say instead of positive over positive, which we know is exactly the same, we could do negative over negative, and we could count that off down 1 to the left 4. These are all points on that same line. If I were to extend this line out, let's see, it would also go right through that point as well. All right, continuing on, we have one here that we're going to form the equation for. Do that in white. There we go. So y equals, this will be my slope, and this will be my y-intercept. So let's take a look here and see what we have. So y-intercept is definitely 1, and it is a positive 1. And for slope, we're going to do our vertical over our horizontal. 1, 2, 3, and that's up, so it's positive. 1, 2, that's right, so it's positive. So my final answer here is the equation for this line is 3 over 2 x plus 1. And it's really just as easy as that. So let's go ahead and graph one. Also, just to practice that one more time. So let's say y is equal to 3x minus 2. Let's see what that looks like. All right, so immediately my y-intercept is here. It is a negative 2. I'm going to graph that, do this with a black line. And then my slope is 3 over 1. And again, slope makes me very happy. This is going to be my vertical movement. This is going to be my horizontal movement. Because this is positive, I'm headed up 3. Because this is positive, I'm headed right 1. So let's count that off. And from here, we're going to go up 1, 2, 3. And we're going to go over 1, making our second point right here. Looks like these lines are going to cross. And we will grab a line here. And eventually, looks like these lines are going to cross, and that's okay. About there. And then let's add our arrows to make sure that everybody understands that that's going to go on and on and on, both directions. All right, so let's take this point just to check. This point is 1 for my x and 1 for my y. And we're going to see very easily that that is a solution to our problem here. So 1 is going to go here, 1 is going to go here, and 3 times 1 is 3. 3 minus 2 is 1, and does 1 equal 1? It sure does. That means that that is indeed a solution for our equation. All right, this is going to be where we're going to check and correct. So you have a line here. You're going to come up with the equation for that line. 2 things to do. And you're also going to graph this equation. All right, so stop the video in just a moment, do the 2 problems, and then come back and check and correct your work. We'll see you in a couple of minutes. Welcome back. We're going to begin by graphing this line, and then we will find out the equation for this line. So our graph here is going to start with a y-intercept of -1. So that is our first point. And then we're going to use our slope, 3 over 1, to count from there to form a second point and form our line. So again, positive, I'm going to go up. Positive, I'm going to go right. So here we go. I'm going to count that off. So 3 up, 1, 2, 3, and 1 right. Puts me right here, which means my line looks like this, and I'm going to add my arrows here and here, and there we have it. So the solutions for this linear equation are all on this line. Now let's take a look at our second problem, which was to write the equation for the line that was already there. So let's take a closer look at this line. I can see that the y-intercept is right here at -2. So I immediately know my y-intercept, or my b, is -2. Now I'm just looking for my slope, and I'm going to go from here to here. So we have a lot going on here, but we're going to count it off carefully. So that's 1, 2, 3, 4. So that was 4 up, and then 1, 2, 3 to the right. Those are both positive movements. So the equation for this line is 4 over 3x minus 2. Hopefully that's what you have as well. All right, finally here we have the working on your own page. So again, you are going to find the equation for the blue line, and then you are going to graph this equation. And there you have it. Make sure you do this right away. It's good for your brain to exercise when everything is good and fresh in your mind. And as always, thanks for advocating for yourself and watching this video. And peace, love, and pie to all. Have a great day.